keynote sessions. The final item on the agenda is a panel session for you, the title of which is Beyond 2020, the Future Direction for Fixed Access Network Technology. If I could please invite to the stage the panelists and also the host, which is Petroc Wilton from Comms Day. Thanks very much.
Awesome. We are almost back on time, and I promise faithfully to get you guys out of here by 4 o'clock for drinks. We will kick off with each of our panelists just introducing themselves, their companies, their experience, which bits of the active technology puzzle they are part of, and then we'll go a few questions from me, and we'll throw it open for you guys. Ronan, let's start with you and just come down the line. It should be okay.
So, good afternoon, everyone. Can you guys hear me okay?
Yeah.
Perfect. Okay, so my name is Ronan. I'm Adtran's CTO for the NBN APAC regions. As I mentioned earlier, I also serve with the Fibre to Home Council for Europe, where I've served as the president of that organisation for the last couple of years. Just by way of background, I've well over 20 years now working in the telecoms space, both as a vendor, but also as an operator as well. I've had a lot of experience building out fibre to the home networks, fixed wireless access networks, and fixed broadband traditional copper networks as well. So a lot of years behind me, a lot of hard lessons learned over those years as well. My organisation, Adtran have been around for 30 years now at this point. They're very much focused on fixed broadband services. More recently, they've started to spread their wings a little bit in that space, focusing on the cable side of the industry as well, and also on the fixed wireless access side of the industry through partnership also. We're very much committed towards gigabit society, as you may have picked up on from my talk earlier. But really the core focus of our strategy as we go forward is a focus around building open software-defined access networks, and the open piece of that being the key. We hear consistently from the industry the pain that operators go through in trying to launch new services and new capabilities, and the lock-in that they've experienced with a lot of the vendor solutions from the past is part of the pain, or a primary driver behind that pain that they face. So at Adtran, we're very much committed in working with the standards community to really open up the industry as we move towards this 5th generation of access networks.
Awesome. Thank you. 3 minutes, 12 seconds, go to start. Els, what you next?
I'll keep it a bit shorter. So my name is Baert. I work for Nokia. I'm leading the strategic engagement in Oceania for fixed networks. My background, so I've been in fixed networks for 8 years now. I come from Belgium, which is one of our leading R&D sites for fixed networks. I've been in marketing, and now I'm working from a Nokia side to help NBN deploy the best network.
Thank you.
Steve Collins, CTO at Netcomm Wireless. Netcomm is an Australian products design company, so my background has always been to design and manufacture devices. That's what I do, and that's what Netcomm does. Our path to market at Netcomm really is not so much taking products and just trying to sell those products through to our customers, which tend to be operators, but more about purpose engineering, taking a number of technology building blocks and listening to our customers, and then creating purpose or custom designs to solve connectivity problems through to the end user.
Thank you.
Good afternoon. I'm Kiran Solipuram from Cyient. So I'm a solutions consultant. I generally support my clients bringing the solutions and systems. So I come with a telecommunication background of 19 years. I implemented different copper, fiber coaxial networks over the globe, so around the globe. So my company basically, we run, plan, build, operate offerings. Either they are offerings or solutions or services. So we work closely with our clients, understand the challenges. It's kind of consulting mode we bring to our clients, and we add value in resolving the problems or filling the gaps, especially between the plan to design or design to operate. So kind of solutions we bring, software solutions, or NOC dashboard solutions, or plan design solutions, or systems, we integrate systems between different vendor equipments. Thank you.
Kiran?
Thanks very much. Thank you. My name is John Goddard. I'm Chief Executive of C-Cor Broadband. We're an Australian firm, wholly owned. We're a mix of a distributor and a manufacturer, so we do produce some component parts. We have been in the HFC industry, the cable industry, for more than 20 years, so we've got significant stakeholding in what occurs in the industry and have been an industry supporter for that 20 plus years. I just want to say what a pleasure it's been to attend this conference. I think it's terrific, and some of the keynote speakers and other presentations were superb, so thank you.
Thanks very much indeed. All right, let's start with access technology. Eeny, meeny. Let's start with FTTN because it's the oldest one and that's kind of historically appropriate. All right, so FTTN has had some mixed reviews in the Australian press, but what are the arguments for it? What about upgrade paths? So we've heard a little bit today about, I was looking at I'm going to get it wrong. Okay, V+, also known as 35B, also known as super vectoring or hypervectoring or some such from DT. Okay, is that practical in the Australian context? And finally, what about the really cool kind of left field stuff coming out of California, I think right now, such as using waveguide in cable sheets and even more crazy things? What can we do with FTTN in Australia? Who wants to start?
Okay, I'll start. So we've heard it a few times that FTTN was really about speeding up the deployment and getting everyone as connected as quickly as possible. So that was definitely the right strategy at the time, and it has shown that NBN could connect that number of customers in a very, very short time. So now we are at the point where the path is open to do the upgrade and to provide better and more speeds to end users. So you're talking about V plus 35B. It's definitely one of the options. So the cabinets can be upgraded to it. The challenge there is that it will mainly give better services for the end users that already have a decent service. So it's definitely possible. It's just a line upgrade, a line card upgrade. Then the other one is G.Fast. As NBN has announced, they are doing FTTC with G.Fast. So it's just a matter of bringing the fiber deeper to the point where it makes economic sense.
I'm going to come back to G.Fast in its own special category in a second. Anybody else on FTTN? Fransky?
So, a couple of things. One of the things that consideration is required for is coexistence. This is where, in a world of vectored VDSL and GFAST coming further down the track, coexistence isn't too big a concern. But when you begin to move up into super vectoring technologies, further consideration is required because you're ultimately going to have to sacrifice the bottom 40 megahertz of spectrum to have that coexistence, and that's the most valuable spectrum as well. It's where you get the best bit loading. So longer term planning is required with regard to what your bandwidth strategy is as a service provider. If you're serious about doing G.Fast, particularly from a DP type location or a PID location like you have here in NBN, then you've really got to give consideration around, loop rearrangement, etc., and ensuring that there's no coexistence in the last piece of the network. The other thing that you touched on, the waveguide technology that's coming out of California, John Chaffee is driving that activity, and fascinating to see. I spoke with John in detail about it on a couple of occasions now at different industry events. I believe there'll be a role for it within the industry. I think one of the challenges is the concepts that are built around it. It doesn't go around corners too well as part of the problem. And in practical deployments, I think that's going to represent a challenge for access networks. However, for backhaul type networks, particularly where you've got large amounts of overhead cabling, it certainly may have a role to play in the future.
Hey, just a quick one for my clarity on losing the spectrum. On coexistence, is that a temporary thing when you're masking spectrum for legacy DSL, or is that indefinitely into the future?
No, it's temporary. So when you get the last customer off the legacy technology, then you can re-release that spectrum.
Sure, thank you. John, did you want to put something in on the cool kind of new kind of coming DSL stuff, or?
No.
Okay. In that case, we will go to G.fast, which is its own special little thing. NBN is currently testing G.fast. How is it going to look in the Australian environment? Do we need DP to make it work? What other kind of tech innovations may we see in Australia? Also 106.212, which is best, it says here. Steve, what's that on?
Sure. Thank you. So we're talking about in Australia, there's a particular geographic arrangement of how the cables and everything work. So with G.fast, you can run a much higher speed than you can with VDSL. The physics there is that we are shortening the line length as well as the higher modulation rate. So to get the benefit out of G.fast that you want, the idea is to get as close as you can to the endpoint to make that work. You're really looking at 200 meters maximum before it's, you can go a bit longer, but that's where it's in its sweet spot. And for 212 profile, which is the new one, it's around 100, 150. In Australia, those sort of distances really mean being in the pit, in the street. If you go all the way to the cabinets that are around the suburbs, that's usually too far, and the condition of the copper between the end premise and the node is slightly undesirable. So G.fast, it does look like the pit is the ideal place to put the G.fast unit. Though in other parts of the world, they're making G.fast work perfectly well from a cabinet, from fibre to node. We heard from OpenReach where that's exactly what they're doing. So it's really a matter of what is the right solution for the geography at hand and what is in the ground and how that copper in the ground has been deployed. In terms of what profile do you use, well, it depends when you get started. If you're starting today, then the 212 profile is the new standard. That's the one you would do. The silicon is ready for showtime around about now. You can buy volume of that early next year. But 106 is what's been available. 106 meg profile has been available for a few years, and so if you started when OpenReach started, then you would have done that. So it's whatever tools you have to hand when you've got your program, when you've got funding to go and do it, you pick the right tool for the job at that point.
On that note, I've got to say that I lose track. We write so much about different G.fast trials, deployments around the world. Are there any particular other geographies which are on a similar time frame to us in Australia that we maybe should be looking at for the best way of doing this?
I'll answer that one. So I think there are definitely multiple operators around the world that are doing G.fast. It all depends on how close you can get to your end user. So the thing is, I mean, if I can just maybe take one step back, the 106 versus 212. 106 means till 106 megahertz, 212 means to 212 megahertz. It's just the fact that the higher frequencies just don't travel that far over the twisted pair. So the closer you get to the higher, the more frequencies you actually get to your modem. So it's all dependent on how close you can get to your end user. In Australia, there is this asset of a pit where you connect 4 homes to a pit. Not every country in the world has that. So for other operators, the FTTC type deployment with a 4-port DPU might not make sense. There, typically, you would see it in buildings, where you install a DPU or a shelf in the basement and run G.fast from there. Also, the BT case, they might have homes that are closer to the cabinet, so their G.fast from the cabinet does make sense, or at least for the ones close to the cabinet. So it's all really dependent on your loop lengths and how long they are really.
Maybe if I could just expand on that briefly as well. Particularly with regard to large-scale deployments, you know, we've got operators like Swisscom, for example. They're pushing heavily now to what they refer to as fiber to the street, slightly further out than the PIT deployments here in the US, a slightly higher customer density in there, slightly longer loop lengths. You've also got different approaches as well, particularly with regard to the medium that G.fast is being delivered over. So for example, in the US market, you've got the likes of AT&T, and they're leveraging the coaxial cable assets that they have at their disposal to deliver G.fast. And one of the big benefits, most of those that are in the room that are familiar with DOCSIS over coaxial cable, the characteristics of that cable versus twisted pair are significantly better. So the rate reach that you can achieve, so the distance you can achieve, particularly with the higher frequencies like 212 megahertz, is significantly greater than what you can achieve with twisted pair. To the point now where we've got the standards, within the standards they're working on 424 megahertz and 848 megahertz, which is bringing G.fast into the realm of 10 gigabits per second.
So a lot of further work coming down the track. It's not done yet as the standard.
Thank you. Anybody else on G.fast?
If I can maybe just comment on that one as well, it's there's a before we all get too excited about G.fast with coax, it does need point-to-point. So I think the challenge there is that most of the HFC networks are built in a point-to-multi-point topology. So it will require most likely a deeper fiber as well, kind of similar as FTTC.
Okay, thank you. Speaking of HFC, that's next. DOCSIS 3.1 is coming. How does this change the speed equation for users? Are we going to need to split more nodes if adoption really takes off? Do we need a load of modems to be upgraded? Is it not quite that much of a rip and replace? How's NBN going? John, you look keen to go for it.
Oh boy, and I get to follow Bill Morrow and Jeff and Bruno, so God help me. I think what we got out of today was that indeed 3.1 is going to be a bit of a paradigm shift in HFC, and it will give significant bandwidth benefits to customers. No argument, and probably with the order of 5 to 10. There is physics involved. And there's also another hidden elephant in the room, and that is that if you look at the Australian context, our networks are going 3.1, but there are some legacy issues, and some of the legacy issues revolve around contracts and revolve around handover, takeover of network. So as Bill told us this morning. So I think we will get the benefits of the greater speeds. DOCSIS 3.1 offers 10 gig down, 1 gig up. So and as it goes into a full symmetrical network, it'll promise 10 gigs each way. One of the problems, of course, is you have to have some plant change to occur for that to occur. So there's a time frame with that. I think distributed access architectures are going to provide a lot of impetus in Australia, particularly in our context, because it can overlay the legacy network. You can have, instead of putting in node splitting with traditional system, you can put a DAA node in the distributed access architecture node.
What about the CPE side? A lot of
CPE side, DOCSIS has always been backwards compliant, so you're not getting full utilisation of the network in that instance, but no issue with cable modems.
I would like to touch base on the network migration, especially the technology migration on the DOCSIS side. So the challenges, generally what we've seen from our experience is whether you go full Big Bang migration or you go phased manner from DOCSIS 1 or DOCSIS 1.1 to 3.1. So that's the biggest challenge what we are seeing, because MSOs sometimes they end up not deciding anything on this point of view. So, but what we recommend, what we've seen is the technology is still under evolution, still needs to go a lot of trials and needs to prove. So what the recommendation generally we see is you don't necessarily split the nodes. You don't need to do that going forward. So you may use DA architectures, distribution access architectures, where the fiber is going. Ultimately, fiber is the game show. But to get there, we need to utilize our existing infrastructure. So to utilize that existing infrastructure, fiber deep architectures are going to go, and then rather than splitting the nodes, you move your 5 devices into the field or into the close to the user, so that you don't need to install new power supply, something like that, because you can reuse existing powers or use the distributed powers coming down from the central location. So that way the DOCSIS can make it happen. And the redesign, and especially when the redesign is happening, the optimization needs to be looked into that, so that the existing infrastructure can be utilized optimally. So the experience what we gained from Liberty Global or some of the cable operators from Germany, Dutch Telecom, Goddard Dutchland. So we have seen these kind of architectures are evolving, but end of the day, the game show is fiber. So we have to ensure that how do we get closer to the fiber using these architectures. That's what we say.
So I would say that it is mostly, so there are 2 ways to get more bandwidth on the HFC. So it's definitely more spectrum, so they can get you more bandwidth. But then the other one is that, different from in the twisted pairs in the copper network, it's not necessarily the length. So like Ronan already mentioned, the coax is a better medium in that sense that it's not dependent on the length of the coax, the amount of speed you can get, but it is dependent on how many users actually share the bandwidth. And that's where node splits actually come from. So it is to reduce the number of homes connected to one node. And that's where, and we've heard it from Jeff today as well, that it is, if you want to do node splits, you have to go deeper in the network because it's just a more efficient way. You can't keep on building new head ends and expanding centrally because it's just not economical. So that's where fiber deeper also comes in, where you have a node in the field serving less users and therefore you can have more bandwidth.
I think one of the points that was just touched on there, and it's the one that we consistently hear back from the MSOs around the world, is congestion within the head end. And I'm not talking about data congestion, I'm talking about physical space for new equipment, challenges with power and air conditioning, etc. And that's also feeding into their decision to move to that distributed access architecture as they go forward. There's no space to expand, basically.
Okay, now on to the end game, as apparently everyone agrees, FTTP. Now, mostly in Australia we have GPON. What upgrade paths do we have? NGPON, El's going to talk about because I forgot what it means. And why is it so difficult for us to do GPON FTTP here compared to other places? Or maybe it's not, maybe I'm just reading what I write. I'll join myself. Or,
sure, yep. Kick it off. So fibre to the prem, as everybody has pointed out, today and at every other conference as well, is ultimately the end game. It's the only future-proof access technology that will, at some point in the future, deliver terabits to the home. One of the decision points that we've got in front of us at this moment in time is how long do we continue to deploy what I would refer to as first-generation fibre to the home technologies, so technologies like GPON, etc. If we look at the trends that some of what I presented today around gigabit society and some of the applications that are coming over the hill, there's question marks as to how long 2.5 gig down, 1.25 gig up will be able to serve a population. And some of that's informed out of your split ratios. We were speaking with Martin from Chorus there last night. He's in the very fortunate position to be running a 16:1 split ratio on his network. So he'll get a lot more headroom out of that versus service providers that are going to 64:1 split ratios. So it just depends on the physical construct of the network. There's a lot of paths forward with regard to the next step, which is a shift towards 10 gig PON, whether that's 10 gig EPON on the cable industry, or XGS PON for the telco operators for fixed wavelength 10 gig PON services, or ultimately taking that step towards converged services using NG-PON2 and multiple wavelengths. So there's a lot of paths forward. There's already talks underway within the standards towards 25 gig and 100 gig PON as well. So we're far from the end of the road. We're only actually at the beginning of the road with regard to fibre to the prem.
So yeah, I think Ronan explained it very well in his presentation that it's not only in Australia that it's hard to roll out fibre to the home. It's everywhere, and it really depends on the environment. Because you asked for it, maybe a short explanation again about the NG-PON2, which is the next generation of fibre. So you have, so NBN has rolled out the GPON fibre to the home network, and what NG-PON2 does is basically just put extra wavelengths on that same fibre infrastructure, so you don't need to change anything in the outside plant. You can basically reuse it, so you can add an extra wavelength that can provide 10 gigabits per second services, but you can also basically, so you don't need to upgrade everyone, you can just add as you grow. And you can even diverse based on wavelength on the different services. So maybe one wavelength is for your business customers and another one is for your residential customers. The thing with NG-PON2 is actually the tunable optics. So you can actually change one wavelength to the other. That's what NG-PON2 gives you, but that is a technology that is fairly new and therefore still quite expensive in the market. That's where XGS PON came in, which is basically NG-PON2 on fixed wavelength using the more commonly available fixed wavelength optics.
Thank you. Mr. Collins, let's go to fixed wireless. I know that NBN has been doing some amazing testing around very cool things and very fast speed fixed wireless, using some more of their spectrum carriers in certain areas. A lot of them I'm not allowed to write about, which is a shame. what's ahead in the fixed wireless space? Can anything be brought across from what's happening in 5G to fixed? And is there scope for NBN to perhaps take another look at how much of its maybe ex-metro footprint is covered with fixed wireless?
Right, okay. The answer is yes, no, and maybe. If you look at fixed wireless, there's a number of different definitions of fixed wireless. So just to be very clear, what I'm talking about with fixed wireless is when you have an engineered design solution from ENO-B base station through to the premise. Now, some operators will call fixed wireless an indoor consumer gateway that gets self-installed. You sell it at a shop, the consumer puts it in their laundry, they turn it on, it doesn't move, therefore it's fixed wireless. And the difference with that solution is the laundry is not a very good place to get RF, and it doesn't perform very well, but that's where the user wants to put it. So I don't call that fixed wireless, I just call that best luck wireless. So the idea of fixed wireless is you have a radio with an antenna. In the case of NBN, it's outside the home. The reason it's outside the home is the spectrum NBN's got doesn't penetrate homes very well. So they're looking for a rural play, so it goes outside the home, they put it up on your roof, it gets purpose engineered installed, and you get a known working link. And what NBN demonstrated, and JB talked about it today, was a 100 meg down service. They do have other technologies that they will have to tune up and release at later times, but that is using LTE Advanced, which is part of the 3GP release track. There is another track for 4G, which is LTE Pro, and that just means more carriers, more lots of 20 megahertz spectrum. So LTE Advanced allows you to have 80 megahertz of spectrum, and on TDD, which is the spectrum allocation that NBN's got, you can get theoretically up to about 400 megabits per second, theoretically, but then you've got to put the network architecture and share that around. So they can do that with the spectrum they've got, but then they're basically going to be out of spectrum. Even if you wheel in 5G onto the same spectrum, not a lot extra happens except maybe some better modulation and massive MIMO, which is more about efficiency on the network. Some speed uplift, but no massive change, because at the end of the day, you're still 80 megahertz of spectrum. That's the physics, unless some fancy modulation technology comes along, which isn't happening in the next few years. So 5G can come along. NBN could, I guess, update their network to 5G. They could bid on some of the spectrum options that are going on. It's going to be a very interesting landscape here in Australia over the next few years, as you've got the existing mobile phone incumbents who are going to be looking for that spectrum versus NBN, and who's going to play for what. Could they share infrastructure? Could they pull resources together? They could. I have no idea how that's going to play out. Technically, NBN is very well placed to do this fixed wireless use case because they have a process, they have a business product that they can take out and offer a guaranteed wireless connection through to homes. And that puts them ahead, actually, of a lot of the other operators in the country.
So basically, simply we just give NBN more low-band spectrum and job done. That won't upset anyone else at all,
That'll be just fine.
Easy. Let's stay on 5G for a second. It was very interesting to hear Mike Matai from Openreach just then talking about how he is very much intent on finding ways essentially to have their version of the NBN, UK NBN, supporting 5G, maybe in the sort of dense microcell network in cities. There's been talk about using NBN fibre for mobile cloud backhaul. They're working with some of that already in a limited way. But you guys can tell me, how easily can NBN's network topology fit with what's happening in mobile on the base stations?
Let me just start by saying that 5G doesn't have to be lots of small cells. Okay, it is if you're talking millimetre wave and if you're talking about the broadband use case. That may or may not be the one that actually gets picked up in the coming years as being the main use case. So yes, having lots of small cells and having fibre backhaul for all them, that makes sense. 5G itself, by the standards that they're writing, has a lot of self-backhauling capabilities built in as well. So wireless small cells, if there's spectrum there, can, if you like, mesh backhaul themselves. Not great for the high broadband use case because you're going to have bottlenecks, but useful for the other ones. Does anyone else want to jump? Yep. Sorry.
I agree with what you're saying. I think there's a few things we could add. NBN already has some spectrum available to it in the 3 gig band, 3.3 to 3.5 fine, I think. They also have a very large broadband network. I think we'd all agree with that. Which offers backhaul capability if they chose to use it that way. They have a very decent fixed wireless network. They have competitors who are currently rolling out plans to customers or modems to customers with just happen to have a chipset inserted, which hooks up to the mobile network should the HFC network fail, for example. So they could do similar things and use the HFC network to leverage a mobile network, giving them the backhaul. There's companies such as Nokia who bought Gainsford, who I'm sure are planning on integrating those two technologies. We know that Casa Systems does it in the US at the moment. So I think there's a convergence of platforms happening, and I think that will allow, in the next 5 years, probably all the technologies we've talked about today to coexist and quite happily. And it'll just be dependent on, the utilisation required in particular areas. Millimetre wave, we've looked at millimetre wave as a company. We've seen it typically as just backhaul. Doesn't penetrate walls very well, doesn't penetrate wood very well. So, even within a home. So very, very, very short distance product, but high bandwidth.
Can I just say I spent half my time writing about how fixed wireless substitution is going to destroy the NBN. All this cooperation stuff is just messing up my narrative. Anybody else on the 5G thing before we thread open to questions? Ronan?
Particularly around small cell, and that belief, I think, within the mobile industry that 5G will serve as a credible fixed replacement. And I personally believe in some use cases it will, as just like 4G does today. There are users out there today around the world that 4G meets their needs, and they're more than happy with that and more than happy with the contracts that go with that. I think there's still a major challenge in the mobile industry. If you look at the cost per bit to the consumer versus the fixed line industry, they're worlds apart. They're not even remotely close. And the 5G industry needs to really address that. I think part of the challenge they have is, when we get into conversations around front haul to these small cells, some of the approaches that are being proposed by some of the vendors in that space, the bandwidths that are going to be required, the latency requirements, it completely dismisses the reuse of a lot of the fixed technologies that could be perfectly viable if some of those approaches were relaxed somewhat. And if they were relaxed and the existing broadband infrastructure could be leveraged, then the cost ultimately to the consumer will be significantly lower. So I think some common sense needs to prevail on that side of things.
Yeah, we had Alan Liu in Comms Day Today, shameless plug, saying, sure, fixed mobile substitution sounds great. We'll see how much it costs on the capex and upfront in his case before we get involved. 5G, anybody else?
So I would like to touch base on the wireless and GPON convergence. So the FTTP is anyways getting built in greenfield areas. So at the same time, the mobile, either it is a 4G or LTE or 5G networks, the backhaul for the mobile is the fiber again. So there can be some convergence things are possible, especially bringing the OLTs or the equipments together with the 5G LTE mobile towers, where you have the OLTs placed on the top of the towers, so that the major problem is going with the convergence of the technologies is the power consumption. So the equipment vendors or the operators should look into that. How do they reduce the power consumption or going to the green environment in the future? So towards that point, we need to ensure that the power is not consumed for each and every elements or each and every equipment. So optimizing the power, locating the GPON equipments, GPON OLTs close to mobile towers, that way the convergence can happen. The traffic can be still at layer 2 level, can be diverted from the mobile traffic to your layer 2 GPON traffic. That way the divergence can happen using this mobile and GPON convergence.
Thank you. At this point, I might open it up to questions. We've got mics knocking around. Please let us know who you are, where you're from, and make sure your questions are questions, not statements, because drinks. Anyone from the floor, the panel? It's an awesome panel. Don't miss the chance. Yeah, everyone's taking drinks. Fine. I'll go in again. Right, so yeah, Robert.
I have a
Oh,
question.
it's a question. Thanks, Alex. Go.
Thanks, Alex from ITY. My question again is about Artemis networks. I mean, they came out with great fanfare a couple of years ago to say that they had a technology which could deliver 5G speeds over existing 4G technology. And in fact, Nokia became a partner of Artemis. They're doing trials. Artemis talks about how they're deploying in San Francisco, they're deploying into all the Levi stadiums. They solved the problem of too much interference by actually harnessing the power of interference to deliver, these tiny bubbles of connectivity that sit right here where your modem is, and they showed your phone is, and they showed this demo where they had the connectivity being beamed right to where they expected the phone to be, and they moved that out, and as I moved it away, the connectivity stopped, and as I moved it back, it was there, and it had 16 iPads, and all of them were running, at the time, 1080p. So why don't we hear anything about this? I mean, we don't even hear anything from Nokia. I mean, is this a dead technology? Are you guys trying to bury it? Why don't we hear about it? It's, why are we going to 5G when we've got this technology which sounds like it does everything 5G does and more? In fact, it sounds like it'll turn 5G into 6G. Why aren't we hearing about it? And from the looks of some of your faces, you've never even heard of it.
I feel like I have to, that you're addressing this to me.
Everybody.
So,
I'm addressing it to everybody.
Unfortunately, I haven't been involved in that particular project, so I can't really comment on it. I'm sure we have very smart people in our Bell Labs organization that typically do a lot of innovative things and a lot of research on what the possibilities are in all kinds of areas, whether it's the core network, the fixed access, the mobile access, with the capabilities on what would be possible in the future. A lot of times we're not capable of talking about that publicly too soon, so it might be a case of that, but on that particular case I actually can't comment.
Has anyone else heard of it?
Questions?
Just a comment like that, particularly in the millimeter wave space, there's a huge amount of innovation going on at the moment. Many different players all jockeying for position. Unfortunately, it certainly helps with positioning, but when you begin to scratch beneath the surface, there is a very significant hype cycle within that space, and there's an awful lot of hype about different approaches and what they'll actually be able to deliver. So, for the company that you've referred to, I'm not intimately familiar with them. I know of them. I've come across some of their tech. I've come across a lot of other companies' tech as well, some of which Adtran is working with. We fully recognize the potential that goes with the whole millimeter wave space, particularly 60 gig, etc., for license-free applications from the DP. But there's a significant need for rigorous testing, particularly with scale, because therein lies the challenge. It's very easy to do proof cases that show, small handful of users, but when you begin to scale things, that's where some of the approaches, the wheels begin to come off, just in my experience.
Just to echo Ronan's points there, what you're dealing with in all the device ecosystem at the moment is pretty much the same silicon technology in terms of its speed and power and heat and how they all play together. The amount of DSP cycles you can do per second. I don't know the Artemis technology either. However, just to echo Ronan's comments, there are lots of companies who are proving and demonstrating these fast speeds. They tend to be isolated use cases, solving a certain problem. And just from what you're saying, it may be that one's very useful in an interference or small distance scenario, but when you scale it up to more interferers or more distances, it may change.
Yeah.
So having one person's proprietary technology isn't how the global community solves problems. It tends to be better if there's multiple technologies, multiple parties contributing to an open standard like the 3GPP, where it scales out to a full ecosystem.
Look, I agree with all of that. I mean, the thing is, these guys were demoing being able to use their technology on existing 4G phones by having a software-defined, antenna, I guess, or broadcasting unit. And look, Artemis, ARTEMIS.com. Go and have a look. There's a white paper. Nokia's done a deal with them. They're deploying them in Levi stadiums. They deployed it in San Francisco. This willful ignorance of this technology just baffles me. I have no connectivity with the company. I have no shares. I saw this and it's like, wow, why aren't we deploying it? And the fact that you guys, who are experts in your field, are telling me, well, don't know about it, don't want to know about it, it's just disturbing. But please go and have a look. artmis.com. Artimis.
I didn't hear anybody saying they didn't want to know about it. So they may suffer from marketing issues, and now that you've helped them with that, we can address it.
Please have a look. It just sounds like it's an answer to a lot of problems, and people are not investigating it. They're just wanting to go down this path.
No, absolutely, it may well be. Like I said, there's a huge amount of innovation going on in that space, so there's a lot of things to catch people's eye and distract them, so we'll certainly take a look at it.
I'd love to talk to you in a year to see what you thought about it when you had a chance to have a look. Thank you.
Sure.
Anybody else on the floor? Okay, all right. I am going to close out with a final question, which you guys are going to love because it's completely tech agnostic. Solve the NBN's problem. What are the hot new applications of broadband that are going to drive consumer demand for faster speeds? Ronan, I was coming in earlier, I think you were talking about VR at very high resolution. Let's start with you.
Yeah, so for me, VR, a lot of hype around it at the moment. For me, VR is always going to be an occasional technology. We're going to use it for gaming, we're going to use it for watching music concerts or sitting pitch side at a football game or whatever. For me, AR is the thing that's going to really move the needle. If we look at the likes of Apple at the moment, Apple, if you look at the direction they're going in, I think Matt there has one of the latest Apple Watches with the SIM built into it, so it's a 4G watch. I begin to marry that with my wireless headphones. Now all of a sudden I get voice control with Siri. All I need now is a set of AR glasses in there and I can get rid of the phone. And if you look at, I've spoken about this for quite a while, but if you look at some of the rumors that are now beginning to leak out about Apple over the last couple of weeks, they're all starting to join up the dots in this way. This is what they're predicting is the next big thing coming out of Apple. So one of the challenges that we have with AR at the moment is we all picture it in our head as like a heads-up display in a car. It's very basic graphics, turn left here, here's the speed that you're doing, blah, blah, blah. And that's really unfortunate because if you get the opportunity to try out the Microsoft HoloLens, you suddenly get a real feel for just how complex that graphic environment can be. And it's every bit as complex as what you can get with VR. And the bandwidth requirements to drive that, coupled with the scenario where you've got 3D sensing taking in the environment to really make that work properly. So it's not just download requirements that you have there, it's also upload requirements to feed that back into cloud compute.
Thank you. Alex, you're up.
Thank you, Peter. Nice question. It's the never-ending question, right? What is the killer application for 1 gigabit? I've heard someone say once the speed test. So it's hard to fill up a gigabit. It's always going to be about more and more bandwidth. Obviously, I also think that we've actually never waited for the killer application to build the network for a certain speed. And it's chicken or egg in a way as well. It's like the application can sometimes only come when you have the network to actually serve the application. So I don't really have an answer for you today, unfortunately.
I got that, Steve.
Wow, sorry to disappoint. So I can't think of a particular application that I think's the game changer. However, one thing I would say is that uplink and symmetric capability to broadband to a home is the ever-neglected leg, if you like, of broadband. It's particularly in my background, which is a lot of wireless and even copper-based technologies. Wireless and even G-Fast are largely asymmetric, more downlink than uplink. And I do think that's an inhibitor to new technologies and new applications. And even the way they architect some fibre networks, they're still asymmetric. And I think if we can, as an industry, move to a more symmetric service, I think that will enable the killer app, which hasn't been invented yet, which is why I don't know about it.
Yeah, there are two things come to my mind when mobility is the word spell out. So I see the networks are getting built up, are getting moved, are migrated, are getting operated. So typical challenges, either it can be for operator side or the MSO side. The challenges is the data, whatever data you call it, is network data or elements data, systems data, management data, or even business process systems data, BSS systems or operation systems data. Getting the data to the right place, right time, to the right hand makes the operation challenges resolved on time. how does it happen? So data needs to be mobilized. So I see mobility will become as a service. Then the field crew, the people who are getting the data into their hands, they need to have some other solution. That's the crew management solution, the auto scheduling, auto tasking, auto management of the data to the people. So I see that these two, data mobility and the crew mobility, they both marry. So I see that most of the operation challenges or the build-up challenges will be resolved using these two solutions.
Thank you. John, your topic.
Finally. I guess, we've heard a lot today about AI, VR, etc., etc. We heard about mission-critical applications. And we've heard about IoT, mentioned a few times. I guess if we think of the billions of instances that IoT could be implemented, that could be a killer app. And it's most likely a killer app that'll catch us unawares. I think with Tesla, what Tesla are doing, Nissan, Toyota, all these car makers going into self-drive, I think that's going to create some killer apps. And it'll be mission critical. So the question then becomes, who do these people entrust these applications to manage? Is it small companies, or is it something of the size and scale of an NBN?
Just one parting comment to keep in the back of our minds as well. While it's always very difficult to use the crystal ball to predict what the next killer app is going to be, one of the things that it's very important that we pay attention to is how quickly the killer app comes to bear on the market. So we're all familiar with the McKinsey type reports where they talk about the time it took a particular technology to get to 50 million users. And they talk about radio being 38 years and TV being 13 years and Facebook being a year. Pokemon Go took 12 days, to put it in perspective. So when the next killer app comes, it's going to come down quickly. And if the networks are not ready for it, you're going to be in trouble real fast.
Thanks, guys. I was secretly looking for some kind of specific stock tips, and I'm getting Tesla and Nintendo, so thank you very much indeed. We are 5 minutes away from being on time, which is pretty good. I'm going to hand you back to Matt, but please join me in thanking all our panelists today.
Okay, I think you've been reminded of drinks, and now that's in your mind. I'm going to rattle through this as quickly as possible. I just wanted to sort of try and wrap up a little bit some of the stuff that we heard today. And I've kind of got 4 things that I've written down that I saw as a theme through many of the presentations from the session. I think the phrase which I heard many times is that we need to be sympathetic to the characteristics of each country when we're thinking about the challenge of deploying broadband. That could be politics, as it's been very much here, but also in the UK where I'm from. It could be geography. We heard from KT that Korea is just 1.5% the size of Australia. These kind of challenges are things that we need to keep in mind. Planning as well is obviously another one. We're not going to see those cables hanging from the buildings in Bucharest, in London, or probably even in Sydney. Those kind of constrictions that we've got make up for a very different scenario in each country when we think about the challenge of deploying broadband. The second thing was around the fact that it seems that often customers just buy broadband based on what it is they need to meet their needs, and quite often that's what it is today that they're trying to try and solve. I think every presentation I saw had a Netflix logo in it, which suggests that that is today at least what it is that customers are thinking about when they're taking out their broadband subscriptions. Many of them, I think, are still in the dark when it comes to technologies that offer faster speeds. They suffer from a lot of confusion when they take out packages, not just on the speed element, but many of the other factors that go with making that kind of decision. And so perhaps that's one of the reasons why we still see low take-up of fibre to the home when it has been deployed. And that kind of leads on to the third point, which is, does it matter if they buy copper, fibre, or even something else. We heard, I think it was, I don't remember who it was now, but someone, it might have been Ronan, said that if we sort of only decide we're going to deploy fibre to the home, then if you're on ADSL in France, it's going to take you 13 years until you get that fibre connection. Why are we sort of only fixated on that one technology when there are obviously others available that could get speed improvements for many people as quickly as possible? And certainly even in Korea, where a lot of people think that everybody's got fibre, and maybe even some people have already got some sort of 5G in their pocket. We know that there is a mix of technologies that have been used to get those rankings that we often see in league tables. Which kind of then leads me to the final point, which is how we kind of measure success when it comes to the broadband deployment. Is it only about the headline speeds that we're focusing on? Or is it something else? Should we also think about the reliability of those networks and the type of experience that customers have? Is it also about the availability of those networks? Rather than just deploying in a couple of cities and saying, yeah, we've deployed fibre to the home, is it about making sure as many people as possible get some sort of speed uplift? And the final one is around price as well. Quite often the sort of league tables that we see only focus on that headline speed, or if you're lucky, some sort of idea about availability, but rarely do we see league tables that focus on price as well. Of course, we can all deploy fibre, but there is a cost to it, and so we've got to make sure that there is that match between the consumer's willingness to pay and the deployment. So those were just a few thoughts from what has been a very, I think, interesting session. I'd like to thank all of the speakers, particularly those obviously that travelled to the event in order to deliver and share with us those experiences. And really, it just leaves me to say that Cisco are sponsoring the drinks up on the 3rd floor, and the staff at the back will guide you to the balcony. So on behalf of NBN and also Comms Day, thank you very much, and enjoy your afternoon. Thank you.